Thank you. Hi. I'm going to talk about blockchain technology, which is quite new technology. But as you can see, Poland has many years of experience in blockchain. So when I started doing research in blockchain, I could see that blockchain is everywhere, like really everywhere. And I also wanted blockchain to be on confidence. So thank you for accepting my paper, my presentation. And whenever you go to any project, startup that uses blockchain, you would see that it's secure, like even cryptographically secure. So it's totally secure. You cannot do with that, anything with that. But on the other hand, from time to time, we can read articles that say that millions of dollars in cryptocurrencies were stolen, frozen, or burned, whatever it means. So my name is Damian Rusinek, and I'm going to try to answer the question, how is it possible that so highly secured projects, applications, can have so serious security flaws? And by the way, I'll also show you how I could steal money, I mean crypto, from exchange worth about thousands of dollars. So who of you has been using blockchain or implementing? How many? OK, so yeah, great. So let's do a quick tutorial of blockchain. Blockchain is like your dude, because basically it's distributed, unmodifiable database. So if you wonder if you need blockchain, you probably don't. But really, if you want to consider whether you might use blockchain in your project, you must focus on three things. First thing is the single point of failure. Can you have single point of failure? That is common right now. Almost nobody can have single point of failure. And you can easily achieve it by mirroring servers using any load balancer and so on. So the second thing that you must focus on is the single point of authority. Can you have single point of authority? All these servers mirrored, can they be controlled by one person, one institution? Or maybe they cannot. If they cannot, you may really need blockchain. And the third thing is the data that is modifiable. If, in your case, you cannot modify data from the past, you probably really need blockchain. So blockchain is like Las Vegas. Whatever happens in blockchain, it stays in blockchain forever. And by analogy, blockchain is little similar to Tor network. It's also a network of nodes that you cannot control, but the difference is that Tor gives you a communication which is private, and basically blockchain gives you a storage that is unmodifiable. And the first and the most popular application of blockchain is Bitcoin, the cryptocurrency, the biggest. And here, the blockchain is used as the storage for transactions between people, okay? But this is the first generation of blockchain. The second generation of blockchain is what's more interesting from my perspective, are smart contracts. And why is it the second generation? Because here, for smart contracts, blockchain is used to store not the data itself, but the programs and their current state. So by analogy to typical executables that we all know, what do you have to do to create a typical executable? You first write the code, then you compile it, and save on your computer server anywhere, and then run it. With smart contracts, it's quite similar. You also write the code of smart contract, which is, of course, you use domain language like Solidity to write these contracts. Then you compile it to the bytecode of the virtual machine. And then you store it, but not on one computer, but you store it in the blockchain, so in the whole network. It's kept in many places at the same moment, and it's unmodifiable. So I've used Ethereum platform as an example here, because this is the biggest platform for smart contracts, and it's also the second biggest cryptocurrency, right after Bitcoin. And in the white paper of Ethereum, you can read that Ethereum is literally a computer that spans the entire world. And that's what it really is. It's like a one computer kept by many nodes in the network. And why would we use smart contracts? The benefits are the same that gives us the blockchain. We have no single authority. We have trustless network, so we don't need any trusted third party. And it allows you to verify the execution and the code of your programs. And how do you think? What particular programs could we run as smart contracts? Where are these benefits very important? In which cases? Any ideas? For example, e-voting. Let's imagine that you can run elections for any president, US, whatever, that could be verified by anyone in the world that has access to the internet. Okay, so it's not controlled by single authority, like the government of the country. And there are also other examples, like for assets management, which means that you can easily transfer the ownership of something, right? And if you use e-voting as an example, you would like to verify the code of the smart contract. So we create a program, a smart contract that runs the elections, and we publish it in the Ethereum. So now you can read its code. You can download it and decompile it, whatever. It's like public exe file or any binary file. And you can use dedicated websites like Etherscan, for example, to view the code of smart contract. Here is the example. This is the bytecode of a smart contract. And the other thing that you want to do is to execute smart contract. So execute some operation in this program. And all smart contracts have the interfaces. And for example, here is an e-voting smart contract which has function vote. And if you want to vote, what you have to do, you have to send a transaction to the Ethereum network. And you do it, firstly, you create a transaction, then you specify which function you want to execute, and you just calculate SHA-3 of the function header, the vote function header, and take the first 4 bytes, which is in red here. Then you specify all parameters. And here is one parameter, which is in red, its value is 0. So this is the data in the transaction that says, I want to call vote function with argument equals 0. And then you specify which contract you want to on which contract you want to execute this operation. And all contracts have their addresses, like unique addresses. Each contract must have unique address. And you specify the address, you create a transaction, and you put into this transaction the data that we just specified, and send it to the network. Of course, there is also some cryptography behind, but that's basically what you do. And then you can verify how it was executed in real, right? So you go to the Etherscan, for example, again, or any other, there are more websites, and check the transaction that you sent. And here is the transaction, which is parsed by this website and says that here the vote function was executed, and the parameter, there is one parameter which equals 0. Okay, so now when we know how it works, the basics, we can go deeper into security. And the first fact to remember about Ethereum and and most, maybe not all, but most of the smart contract platforms is that all data in this platform is public. So one thing that you can specify in your smart contract is the visibility type of your variable. For example, here we have a voters variable, which is specified as public. And this means that we can easily view its values. So voters is some kind of the dictionary. And you go to, again, Etherscan.io, and you can easily, via web interface, check the value under specific address. So you can check who has voted for whom. And here is an example that somebody has voted for option number 0. So what could we do? We could change the visibility type to private. And then if we go to Etherscan again, we see that there is no voters variable to be checked. But it doesn't mean that this variable is really private. It is just not presented on the Etherscan. But you can still view the values that are kept in voters variable. You can do it easily by checking the transactions to this specific smart contract. And you can view all the transactions one by one and check whether the vote function was executed. If it was, you can see the sender of this transaction, so we know who has voted, and you can view the parameter which was sent, as on this example. So you can see on whom this particular person has, for whom this particular person has voted. And the same thing with visibility specifiers is with functions. Functions can also be specified as private, public, internal, external. And the private functions are those that can be executed only inside, so from other functions in this smart contract. And public functions can be executed by anyone, like the vote function, right? So let's assume now that we have malicious function 2. And here there is no visibility specifier provided. So it's like default visibility specifier. And how do you think? Can we execute that function or not? There is no public, private, nothing. Who would say that we can execute? Who would say that we cannot? Yeah, there is one person. Of course, you can, because public functions are public by default. And that was the case of the Parity Hack that was used to steal about $30 million in cryptocurrency, in Ether cryptocurrency, which is cryptocurrency for Ethereum platform. And the problem here was that the init wallet function that was used to initialize the wallet, so specify its owner. So this contract was the wallet contract. And you use this contract to manage your cryptocurrency, your Ether, right? And the problem was that the init wallet function was public by default, right? It's not specified private or anything. So anyone could call init wallet function in your wallet and become the owner, because this function was used to set the owner. And the funny thing about this hack was that there was a race, because as I said at the beginning, the data in blockchain is unmodifiable. Of course, there are some exceptions, but basically, it's unmodifiable. So you cannot just patch your wallet just like that, like you would do with any executable file. The problem is that it's still there, and you must steal your money, right? So the case here was that there were black hats and white hats. Black hats were stealing the money, and white hats were also stealing the money, but later to give them back to the owners. So thanks to the white hats, only $30 million were stolen, and the white hats have stolen another $80 million. But another funny fact is that that was the value at the time of the hack. Today, it would be $90 and $240 million, respectively. So the first thing to remember about fact 1 is that you should set visibility type to all functions, so that you don't forget about one that is quite important. And do not keep secret data as plain text in smart contracts, because anyone can see it. So another example of that secret data as plain text in a smart contract is, for example, a rock, paper, scissors game. What you could do, you could wait for your opponent to check what he has chosen. And if, for example, if he had chosen rock, you would send another transaction, I choose paper, thank you. I choose paper, and I win, right? So how can we fight with that? We can use blind commitments. And the idea here is that you divide your smart contract, your program, into two phases. In the first phase, you send the hashed value of your choice. So no one can see the real choice. You can see only the hashes. And then when the first phase is ended, you start the second phase in which the same people have to send the real choice, like plain text. But now, you cannot send the hash in the second phase. And at the end of the execution, the smart contract checks whether the hash and the real choice for the same person is the same. I mean, the hash is really of this particular real choice, and selects the winner. Okay? Just general idea that can be used for rock, paper, scissors game, or maybe some kind of blind auctions. The second fact is that smart contract is still just a program. So it's vulnerable to the many problems that we may meet when we execute typical programs. And one of them, one of the most common, I guess, are the overflows and underflows. For example, integer overflow. And I'm going to use an example of a token smart contract. Token smart contract is like your own cryptocurrency. You can create a smart contract and name it like your name. I can create Damian coin and publish it as a smart contract. And then I can sell it, give it. I can just transfer this token from me to somebody else, and then somebody else can transfer it to another person. So one of the main functions in a contract, in token smart contract, is the transfer function. And the idea here is that we would like to empty somebody's wallet. Okay, that's the idea of the attack. So let's imagine that there is a victim who has a lot of the tokens, like very many tokens. And it may be a case of the founder of the token. When I create a token contract, at the beginning I have all the tokens, and then I send it to somebody. So let's assume there is a victim who has many tokens. Let's say its maximum value of uint type -9. Okay? And then there is an attacker who has just 10 tokens. It doesn't matter how he got it. And what attacker does, he just sends the 10 tokens to the victim. And thanks to that line, which adds the value to somebody's balance, at the end, they both have 0 tokens, because the balance of the victim circles back to 0. So typical integer overflow. Another case are insecure libraries. Smart contracts can also be libraries. And library smart contract is just a contract that is executed by other contract. So you execute a function on one contract, and then it calls another contract. Of course, the third contract can also call functions from the same library contact. And the problem here is that, again, if you do something wrong with the library, and many contracts depend on this library, you can just destroy these contracts, because they cannot execute their functions, because they have no the library. And that was the case, similar to the previous one, the case of the, again, wallet smart contract. So again, we have a smart contract, which is a wallet. So you manage your Ether via a smart contract. And all of them used our library that was, again, insecure, because it had uninitialized init wallet function. Here you can see that at the end, there is something like only uninitialized. This is the patch for the previous attack. But the problem here was that the library, because it was a library, not the wallet itself, was not initialized by anyone. And at one day, someone tried to initialize the library. And he managed to do it. And what he did next, he called kill function. And kill function removes the library from Ethereum. So all the wallets that use this library cannot exist anymore because they cannot execute any operation, because the library that they want to use does not exist anymore. And that was the problem, quite big problem, because 500,000 of Ethers were stolen. Sorry, not stolen, frozen. It's even worse, because they are there, you have your wallet, you have your Ether there, but you cannot do anything with that. Okay? So, to remember, you should use open source libraries to handle typical errors. Like, for example, there is a very good safe math library for handling overflows. You should, of course, write tests for boundary conditions and verify the correctness of libraries that you want to use. That's quite a challenging task, but still, you cannot assume that all contracts, all libraries that are in the Ethereum platform are secure. Fact 3, smart contracts have some limitations, and this is specific for smart contracts. The most common limitation, I guess, is the gas limit. And the idea with gas is that all transactions, so operations that you want to execute, cost some gas. All opcode in the Ethereum Virtual Machine costs some gas. And when you execute the next lines of code, the gas drops down, right? And if it drops down to 0, the transaction is rejected. And the idea with gas limit is to prevent the infinite loops. Because if there were no gas, you could easily send a function, execute a function with infinite loop. And then whole Ethereum platform would hang. You would perform a perfect DOS attack, okay? Because Ethereum platform would still execute the same loop. So to fight with that, the gas limit was added to the Ethereum. But still, we can use this gas limitation to DOS the contract. And let's assume that we have an auction contract. There is a nice painting to buy, and initial price is 0 Ether, so very best offer, my friend. And what you do, you send, there is a Bob who wants to buy this painting, so he sends 1 Ether, he sends his bid, 1 Ether, and he specifies 100 units of gas, 100 gas. Okay, so he becomes now the highest bidder, and now the price is 1 Ether. So there is Alice. She also wants to buy this painting for 2 Ethers, and that's okay. She sends 100 gas. So the auction contract must send back 1 Ether to Bob, because now he's not the highest bidder, and keep Alice as the highest bidder, and keep her 2 Ethers as the price. And then attacker comes in, and he doesn't send the Ethers, send his bid directly to the contract, to the auction contract, but he creates some kind of proxy contract. This is a contract that is created by the attacker, and all that he does, the contract, it just forwards all the operations. So attacker sends through his proxy contract 3 Ethers, and also sends 100 units of gas. Auction contract sends back 2 Ethers to Alice and uses, again, 50, because that's constant. Auction contract uses 50 units of gas to send back the money, the Ethers. And now, not the attacker himself, but his contract is the highest bidder. And the problem starts here, because let's assume that Bob really wants to buy this painting, okay? And he says, I'll buy it for 4 Ether. And that's perfectly fine. He sent more than 3 Ethers, so he should be highest bidder at this moment. But the problem is that sending money, transferring Ethers to contract and not to the personal address is more expensive. So here, the 50 units of gas, which is hard-coded in the auction contract, is not enough. And the problem is that this would be rejected. So auction contract cannot send back money to attacker's contract, so he cannot accept the new bid from Bob. So further bids are blocked, and the attacker is the winner at this moment. He doesn't even have, well, of course, he must wait until the auction is finished, but he's sure that nobody will send the highest bid. So if you are quick enough as an attacker, you can buy things for very cheap. So lessons learned here. You should learn the limitations of Ethereum. And the gas limit is just one example. There are more, like, for example, achieving a randomness, which is very challenging in Ethereum. You should learn the way of handling these limitations, and of course, write tests for handling these limitations. And fact 4, smart contracts have specific vulnerabilities. And the most common, I guess, is the reentrance vulnerability. And reentrance is just unintended recurrence in the smart contract. And let's come back to our wallet contract. Wallet contract has withdraw balance function, which allows you to get all the ethers from the wallet contract back to your personal address. And what you do, you just send transaction which executes withdraw balance. And what contract does? It checks your balance, so it gets all your money kept in the wallet. It calls the function on your personal address to send you back this amount of money, of Ether, and then it clears your balance. So 3 easy steps. Okay? So that's how looks the whole implementation of this function. And do you have any ideas where the recurrence could exist? How can we attack this withdraw balance function with recurrence? Okay, so let's now use not our personal address, but again, let's create a malicious contract that will call functions in wallet contract on our behalf. So what we do, we ask our contract, malicious contract, to execute withdraw balance operation in the wallet contract. And then, when the wallet contract calls this default function, call value with one parameter function, we tell our contract to again execute the withdraw balance function. And the problem here is that your balance was not yet cleared. So you still have the same amount of money on this contract, on this wallet contract. So you can easily make many calls, recurrence calls, to withdraw the multiplication of your balance. So if you want to test smart contracts, like automatically, you don't want to go deep into security, you can use many tools that are available. And some of them are online tools, like Remix, Securify, and SmartCheck. And some of them are offline, like Solhint, Oyente, and Mithril, very nice tools. And also you could learn or just read best practices by consensus. And the other quite tricky thing is that you don't have to attack the smart contracts themselves. You can attack something that integrates with smart contracts. So the idea here is to attack popular web applications that use smart contracts, that are integrated with smart contracts. And so we don't touch the smart contracts. We want to make the application send a malicious transaction. So let's try to steal some tokens from the exchange. Exchanges are one of the most common applications that integrate with smart contracts. There are also games, wallets, online wallets, or initial coin offering applications. And when you want to withdraw some money from the exchange, like let's assume we have typical exchange website, and we want to withdraw some tokens, Ethereum tokens. And what exchange creates? It creates a transaction which executes transfer function. Here is the executed function parsed by Etherscan. So we can see that the function transfer is executed with two parameters. The first one is address where to send these tokens. And the second parameter is value, which says how many tokens you want to transfer. And the data kept in the transaction is just the combined data. So first 4 bytes is the function, and then parameters. So here we have 2 parameters, so there are 2 parameters at the bottom. So let's try to do some changes in the parameters. Here, if we want exchange website to send money to us, so we want to withdraw some money, we have control over the address and over the value. We can specify on which address we want to send this money, right? We want to withdraw this money, actually. And let's use short address. So the length of the parameter, of the first parameter, is shorter than it should be. And what Ethereum does, it doesn't know where your parameter ends. It just takes the first parameter. The first parameter should be, for example, 32 bytes, so it takes 32 bytes. So what it does, it takes the modified address. Okay, so it takes the part of a value parameter to the address parameter. And now the value parameter is too short. Okay? And the tricky part here is that the thing that Ethereum does with such transactions. Let's assume that you are Ethereum platform and you are given a transaction that is too short. One of the parameters is too short. What would you do? Sorry? You know that. Okay. Well, what I would do, I would cancel that transaction. Because if somebody would really call it, he or she would create a correct transaction. But the problem here is that Ethereum pads this parameter with zeros. So let's look at a real example. Here's an example of executing transfer function. And as you can see, there is no information about parameters because Etherscan cannot parse it because the length is too short. So what we have here is that there is too short address. The address should be 20 bytes with 12 0 bytes at the beginning. And here we have only 3 bytes of the address. So what Ethereum does, it takes the padded address, because it takes the part of value parameter and adds it to the address. And then we have padded value, which is actually just shifted. Right? If we add zeros at the end, we just shift the value. And the problem here was that somebody tried to send 2,000, almost 400 Golem tokens, it's one of many tokens, to this 79735 hexadecimal address, which is, of course, a mistake. This is not valid address. But what Ethereum understood, it understood that somebody wants to send 2 times 10 to 45 Golem tokens to padded address, because the zeros in the address are the zeros from the value part. Okay, so from here are these zeros. And the zeros that were added are the zeros that shift the value. And this particular transaction was rejected, but not because it's too short, but because there is no so many Golem tokens. If there were so many Golem tokens, and if somebody really had this address with so many zeros at the end, he or she would get quite big amount of tokens. So my idea here is let's do the same with exchanges. So I'll deposit on the exchange 1 token, then I'll generate the Ethereum address with 1 0 byte at the end, and it's a matter of seconds, like 15 seconds, and I have 1. Then I'll try to withdraw 1 Ethereum token and send this address, but without the last byte, so without 2 hexadecimal zeros at the end. And how many tokens would I receive if the attack success? It's padded value with 1 byte, and I deposit 1 token. So I should get 256 tokens. And here is the transaction that I managed to do on one exchange. I tried like about 20 exchanges, and 5 of them were Chinese, so and required verification, so I didn't want to send my ID to China. And actually, I didn't send ID to any exchange. And I just checked those that I could use without verification. And I have found one which didn't check the correctness of the withdrawal address. And this is my transaction, which is 1 byte too short. So Ethereum, again, took 2 zeros from the value, added 2 zeros at the end, so the value is shifted, and address ends with 2 zeros. And I have deposited almost half of Golem token. I tried to do this on small amounts, not to empty whole wallets of the exchange. And I withdrew approximately 120 Golem tokens. So it's like 256 more, times more. So the problem was that when I found it, I was like very happy. Okay, I stole some tokens from the exchange, so I wanted to report it. And the problem was that I didn't know where to report it, because on the website, crypto exchanges are divided into two. Half of them are like very like banks. You know who's behind this website. You know who to contact. They have very good responsible disclosure practices. But the other part of exchanges is like nobody wants to sign over this exchange. So nobody wants to be connected with this exchange because, you know, it's the cryptocurrency world. In many countries, cryptocurrencies means doing bad things. So the problem was that I had here was that there was no information about the owner of this exchange. And I didn't want to send this information about critical vulnerability to anyone who is on the chat of this website. So I had to be like a Sherlock and find this guy, the guy that owns the exchange. And remember that time is running. So anyone at any time can use this vulnerability to empty their wallet, like with the Parity race. So I started to look for him. Actually, I found him, but I stopped at one moment and said, well, this is a quite general problem. So how can we responsibly disclose the vulnerability in smart contract? How to inform the owner of smart contract? We don't know him. We have just his Ethereum address. That's all you've got. And you have 2 options. Either you steal the ethers or tokens, anything. You just steal and then find the owner. Or the other option is like you try to find the owner and hope that nobody else uses this vulnerability and steal the crypto. So what would you do? Would you be a thief and try to find the owner? Or would you be like ethical and hope that nobody else steals it? Who would steal and find the owner? Okay, there are a few people. So my idea was to make sure that nobody thinks that I am the thief. So I want to send an encrypted message on Ethereum saying that, look, I have stolen your money, it's here. Okay? It's on the other address, and here is the private key to the address, or any kind of password. And this message is kept on Ethereum, so it's unmodifiable. I cannot modify it later. So it's like I'm ethical. It's encrypted, so only the owner can read it, and nobody else, because only the owner has the private key of the smart contract. And my idea was to create a tool that is used to 2 things. Send this encrypted message to the owner of the smart contract, and as the owner of the smart contract, decrypt this message. So let me try to show you how it works. Oh, okay. I have a vulnerable smart contract and its address. I use, for example, MetaMask plugin, which allows me to communicate with Ethereum. I don't have to write the communication, implement the communication myself. I can use existing wallets like MetaMask plugin. So now I'm an ethical hacker. I have found that there is a vulnerability in this particular smart contract. So what I do, I paste the address of this contract. The program loads the public key of the owner of this contract. Okay, sorry. Okay, so I pasted the address of the contract here. I load the public key. Here is the public key of the owner of this address. I specify the message. Oh, I can't even write my email. I encrypt it. So here is encrypted message, and I send it. Sorry? OK, doesn't matter. And I send it. And OK, because I have enlarged it. OK. We didn't pray too much. Let me show the backup video. OK, I have problem with yeah. Sorry, could you help me with the muszę przeciągnąć. OK, so I copy this address. I paste it again. Load the public key. Specify the message. At least here the address is OK, an email. And encrypt it with the public key of the contract owner. I send it using MetaMask, and now I'm sending the transaction. So I'm trying to execute some function in this contract, but actually I'm not using any function. I'm just sending some bytes. And here is the transaction. It has to refresh. We have to wait a few seconds, because the time when the transactions are verified in Ethereum is like about 15 seconds. So when you send a transaction, you must wait like 15 seconds to actually view it in the Ethereum platform. So I'm trying to refresh the page here. OK, here the transaction says it has failed. And that's completely fine. I didn't want to execute any function in this contract. I just wanted to send these bytes. OK? So even if the transaction fails, it's still kept on Ethereum. So here is the data, encrypted data, and I have added an information for the contract owner to visit a particular page. And when he visits this page, he's redirected, of course, to my tool. And what he has to do, he has to, yeah, I'm now the contract owner. Okay, so I'm the other person. Now I'm the contract owner. And what I have to do as a contract owner, I have to paste in the ID of this transaction to my tool. Then load the encrypted message. Then paste in here the private key. And this is not like application with a backend. This is JavaScript only. You can check it. So it's not sent anywhere. And it's publicly verifiable. So I take the key, paste it, and decrypt the message. And here is the message, okay, for the contract owner. And he can view this message, and only he can view this message. Okay, so to sum up, in smart contracts themselves, we have two kinds of vulnerabilities. The ones that we know from typical programs, like overflows, unauthorized access to functions, insecure libraries, or some kind of business logic vulnerabilities. And on the other hand, we have also specific vulnerabilities for smart contracts, like those related to the limitations, those like very popular ones like reentrance, and of course there are more. These are only few of them. And to remember, things to remember when you handle some smart contracts. First, remember that all data is public in the blockchain. So do not keep secret data as plain text. Use blind commitments instead. And set visibility type to all functions and all variables. Learn the limitations and learn how to handle them, how to make sure that you don't use not enough gas to send some transaction. Of course, write tests for handling, and there is a quite nice IDE for smart contracts and decentralized applications. It's called Truffle, very nice tool. And verify the libraries that you plan to use. So do some checks, even the basic checks, because the problem with unsecure library that I showed you was like very easy to find, right? It was just the function that was public. So if you use these tools that I showed you to verify the libraries that you want to use the best security practices, so learn them and keep them on the side and just watch them regularly. And of course, consider threats from applications that integrate with blockchain. And of course, last but not least, test your contracts and blockchain applications as a whole. And if you are interested in hacking smart contracts, I invite you to take part in our contest. We are planning contest. It's not online yet, but follow us on Twitter, Securing and me, and we're gonna publish information when the contest started, so you can hack some smart contracts and win some prizes. And if you are interested in the presentation, just drop me an email or catch me next to the Securing stand, and I'll send it to you. Are there any questions?
What happened with the exchange case?
Sorry?
What happened with the exchange case?
I found the guy. Actually, we are colleagues now, the owner of the exchange, and they didn't have bug bounty program. But when I asked them if they did, they said no, but they probably should start one. And actually, they did, because they gave me some bounty. And the exchange works till now. But there is another case of another crypto exchange that was closed right after I sent them a report about some kind of vulnerability they have. But it's the other exchange. So this is more interesting. And if you want to know the case, we can talk later, because I guess we are running out of time.
There was this case when the gas run out when this auction was going on. So I have a question, because you said that it costed, I think, 50 of gas, whatever. Where is it? It's like the owner of, the creator of this code told that it's hard-coded. You can do that actually, right? To say that this costs 50 and this costs something else. I'm just
exactly.
wondering.
You can specify it. You can specify it, and that was the case in this example where you because you assume that sending Ether to address, and you keep in mind personal address, of course, cost, for example, 2,300 gas. And okay, so I'll give it 2,500, and that should be enough in all cases. But there is that special case with contract, and when you send money, when you send Ether to other contract, it costs more. So it was like hard-coded here. Hard-coded here. Any more questions? Okay, thank you.